Good evening. This is our second video of our topic set, and again we're just covering our things on the kind of backgrounds of science. And so some of this might sound a little bit familiar, especially if you took chemistry, because a lot of this we covered quite extensively in chemistry when we looked at making measurements and significant figures. Now I'm going to have a little different, a slightly different set of rules when it comes to significant figures in this class. But I think that you're going to find that it's going to be more manageable maybe, and we may be adjusting that even when we start talking as chemistry teachers at some point. But we want to start today with our discussion on making measurements, and I actually have a book that I'd like to read a little bit about, or a little bit out of, and it's called How Tall, How Short, How Far Away. Again, I like to find different places where this is illustrated or where different concepts can be illustrated. And there's a number of different children's books that deal with some things. And I thought this was a good one to start with. And so I'm just going to read a couple of excerpts out of this. It says, "How tall are you? How long is your block? How far away is your school? The only way to answer these questions is by measuring. People have been measuring things for thousands of years." Okay. In ancient Egypt, fingers, hands, and arms were used as measuring tools. The width of one finger was a digit. The width of 4 fingers was a palm. Open your hands. Stretch out your fingers. The distance from the tip of your thumb to the end of your little finger was a span. Now bend your arm. The distance from your elbow to the tip of your middle finger was a cubit. Okay? So you can see that they were making some measurements, but they were making all their measurements based upon something that they had available to them, and it's usually a part of your body. So again, you're measuring like the width of your finger or the width of your hand, or the width from here to here was the span, and then from here to here was a cubit. Now, that would be a great way to measure as long as you're the only person that's making the measurements. And I'm guessing that you could see where the problem might lie, and it would lie with the fact that not everybody has the same width of a finger, or from elbow to tip, it wouldn't be the same. And so we're not using common tools, okay? And that's kind of the thing that we start to look at. Now, they do go through and they make some measurements of these kids and trying to find out how tall you are, and so you can find that out. And you might find that you wouldn't be the same as if your friend did this measurement. And then they go into like finding the length of your block. And it says to try to measure the length of your block, take your friend and an adult to one end of the block. Count your steps as you walk to the other end. Every 2 steps is a pace, a measure used in ancient Rome. You and your friend and the adult walking with you may each get a different answer. And that's because the length of your step is different. Okay? If you were to measure a greater distance, perhaps the distance from your home house to school, you might measure it in miles. In ancient Rome, 1 mile was measured by counting 1,000 paces. Okay? So now all of a sudden they're talking about a unit conversion. So they're going from this unit of pace into miles. And they had kind of a set deal for miles. The problem is that not everybody's pace is the same. And so we didn't always get the same distance. Now, it wasn't until they invented a tool, okay, and this is what we started talking about in science, is looking at tools. A tool like a ruler is a standardized thing to make measurements with. And that's typically what we do, is we start to look at making measurements against a standard. Okay, so they say, of course, kings would not travel from house to house to measure things, so standard measuring sticks were made. In different times and parts of the world, there have been many systems of measurements, and today only 2 systems are widely used. The customary, or inch-pound, system is used in the United States, and the metric system is used almost everywhere else. So we are going to look at different systems of measurements as well. Okay, and so then we started to say, well, now we're not going to base it on this, we're going to have an actual standard. And then we started to measure our foot, and a foot was 12 inches, and an inch is about the width of a thumb, and so they started to use those as some standard things. All right, so we get into our different systems of measurements. Now, again, the problem is that we want to have tools that kind of tell us how good is our measurements, okay? And the tools that were connected to our bodies are not great tools. They could give us kind of a good approximation, but they wouldn't do justice to when we're making precise measurements. All right. So now with that in mind, we start to look at different rulers that we can kind of work with. And let's see. So now I've got 3 different sticks, okay? And a stick is nothing more than something that can make a measurement. And if I wanted to measure something, I could measure from here to here, and that would tell me that I would have 1 stick. Now, if I wanted to make my stick a better measuring tool, okay, and this is typically what we do with our meter sticks, is we add more lines to them. I could make some more subdivisions. So like if I divided my stick in half, okay, and then I said, let's see, this is 1, 2, 3, 4, 1, 2, 3, 4. I could get divisions here, and each division would then be, if this was 1 stick, I would then have this be 0.1 of a stick, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then finally out to 1 stick. So I could measure anything with like this one right here, good to a whole stick, okay? This one I could measure to 1/10 of a stick with certainty. And I might have an object that was maybe like a pen or something, and maybe the object is, maybe the object is something that looks like this, okay, and this is my pencil, there we go. And my pencil might come out to be in between these 2. Now this is where we start to talk about this in terms of significant figures, okay? Now in chemistry we talked about some rules to significant figures, and it was about counting numbers and knowing where the zeros were and all that kind of stuff. And really the whole purpose of doing that was so that we understood how smart our tool was, okay? In this particular sense, this tool right here has a 0 mark and it has a 1 mark. Okay, and there's no lines in between it. So this is not a very smart tool. This would be my dumb stick. Okay, now this stick right here is again a little bit smarter. It's a smarter stick because it has lines on it. We say that it's then graduated. And so a graduated stick has lines on it. Now if I wanted to, I could take the same stick here, okay, and I could put more lines on it. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I can make my divisions in between here, and so then I get a smarter stick, okay, because it has more lines. So the more divisions that a tool has, the more significant figures that it can have, and it's essentially a better tool. Okay, so we go from the dumb tool to the smarter tool to then the smartest of all tools, okay? Now we go on here, and I'm going to show you some pictures of some examples. So like this is a scale, and you're going to have to use a scale in tomorrow's little activity. So we're going to measure a mass of some chewing gum, and so we have to be able to read the scales properly. Now this is a triple balance beam scale, so it has 3 beams. So it has 1 here, 1 here, and 1 here. Now this scale right here is measuring in the hundredths, so this is the least precise of all of our measurements, okay? So we could get only within, say, 100 grams when we're using that one. This one uses at the tens position. This last one, though, is the one that goes to the whole units, and then we get the divisions that show the tenths, and then we can then start to make guesses in between, okay? And we're going to start talking a little bit about what a guess means. So now, and I'm guessing that you may see that the picture, and I apologize, my picture's probably over the top of this, so I'm actually looking on this. But this slider right here is set to 0. So I'm less, or I'm more than 0 grams, but I'm less than 100 grams. So that's essentially what this slider tells me, is that I'm sitting on the 0 mark, and I know that I'm more than 0 grams because I have some mass on it, but I'm less than 100 grams. My precision goes up a step when I look at the back slider. The back slider now is in between, it's actually on the 30 mark, not on the 40 mark. So I know that I'm more than 30, less than 40. Then I look at this slider right here, and this slider slid over, and I should see that there's a 3 here, so I'm more than 33 right now, but I'm less than, say, 34. Then I have another line that shows me another division. This division shows me tenths. So I'm now 1/10, 2/10, 3/10. I'm more than 33.3, so I'm more than 33.3, but I'm less than 33.4. Then I get to a point where my slider is not necessarily on a line, okay? It's in between two lines. And anytime I'm in between two lines, I then have to make a guess, okay? And I'm going to make my guess here to be at something like closer to this line than it is the other. So I'm closer to the 0.4 than I am to the 0.3. So I'm going to make my measurement to be 33.3, and my guess is going to be an 8. I'm going to label it as grams, and that's my measurement. So this scale gave me 4 significant figures. And significant figures is just the numbers that are off of the tool plus that estimated value or that guessed value. So I had certain, 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 uncertain, but it was my guessed value. And I can have one of these, okay, because tools are not going to ever be perfect. There's always going to be that guess that a human's going to have to make. Or there's a guess that's built in because it's a digital device, okay. So again, there's always going to be a little bit of uncertainty with any measurement that we make. But that's what we're talking about. And this is why this is important. Okay? I'm going to just show a quick couple here. What you may want to do is you may want to pause right now, see if you can make the measurement, and I'm just going to put the measurements up here. Okay, so pause right now. Okay, now you're back after you have that. And so I'm looking at this, and I'm going to say I'm 67 point, and now I'm more than 67.0, less than 67.1, and I'm going to say I'm 0.5, okay, grams. And so that's how I could read that one. Again, the next one you may want to pause this one. And I apologize if my picture's on here. I didn't pre-check that, so we'll see. But this one, okay, if you come back now, okay, is at 60, and we're more than 66. We're 3/10, but we seem to line up on a line. And whenever we line up on a line, we put a 0, okay? And that 0 becomes an important number. It's an important piece in my measurement. It tells me how smart my tool was, where my level of certainty was. So again, I was certain on the 6, certain on the 6, certain on the 3. My guess came out at 0, but I wanted to make sure that that was there. If I had written 66.3 and told that measurement to somebody else, they would have thought that my guessed value was there, and they would have thought that I was using a dumb scale. I was not. I was using a smarter scale, something that measured with certainty to the tenths with an estimated in the hundredths. Okay? Now I'm going to kind of go here quick here with some of my significant figures. I'm just going to put them all up here because I notice my time's running short. Okay? These are all essentially measurements that were made with different tools. Okay? And I should be able to know where, where the guesses were and where the uncertainty was. So like this one, always the uncertainty is the end. So in other words, that's my uncertain, 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 that's my uncertain. And then, this one we're going to talk about here in a second. But anytime I have a decimal point, I always know that the uncertainty is always at the end. Anything that precedes it is a certain figure. Okay, so in other words, I have 1, 2, 3. That one has 3 significant figures. This one has 1, 2, 3. That one has 3 significant figures. This one has 1, 2, 3. That one has 3 significant figures. This one only has 2. Okay, and you might say, well, why 2? This 0 doesn't count. Okay, just like this 0 is not going to count, this 0 is not going to count. This one has 2, this one has 2, and this one has 3. Now this one that has 3, again, is different because these 2 zeros are acting as placeholders. And I can see that my time's going to run out, so I'm probably going to explain a little bit more about significant figures in class, and especially when it gets to doing our assignments. But again, it's about the fact that we have a tool that made a measurement, and that's kind of what it's about, and we'll talk more about that if you have questions tomorrow. All right?